Hello guys, welcome back to our channel. Today we are going to discuss about what is a PISO. PISO is nothing but the parallel input and serial output. This is the third type of these shift registers. Already we discussed two type of shift registers, which is nothing but the SISO and the SIPO, which are already available in our channel. Okay, now we are going to discuss what is this parallel input and serial output shift register. In the name itself, it is a parallel input and the serial output. That means the input will be parallel. So if we give a 4 bits, it will take directly 4 bits at a time. If we give 8 bits, it will take 8 bits at a time. And serial output, that means the output will become bit by bit by bit. That means if we are now in this video, we are discussing about a 4-bit parallel in serial out shift register. So it can take 4 bits at a time in one clock cycle, and it will give those 4 bits at the output within 4 clock cycles. Okay, I think you understood that one clock cycle is required for the input and 4 clock cycles are required for the output. Now we will see how the circuit will be operated. Here we have a signal called shift or load bar. That means if load is high, that means 1, it will give the output. That means the shift will be active, and the load will be disabled. So what are the inputs in the circuit will become outside, and if load is equal to 0, then load is nothing but the active low signal. When the load is 0, then the circuit will start taking the inputs from the will start input. Now we will see here first. Now I want to give the input as 1 0 1 0, like that. Now what will I do? The first bit 1 will be directly given to the 1. Okay. Next, second bit is the, here I will write this D3, D2, D1 and the D0. Okay. Now what will happen? I am making the load as, now I am making the signal load is equal to 0. Load equal to 0, that means 1, the load will be active. So here load will be it is the 1, and the D2, the output will be D2. Here the shift signal is 0, and irrespective of the other input, the output will be 0 because it is an AND gate. Now D2 and 0 will be D2, so the D2 will be given to the second flip flop. Okay, now the input is 0, here 1, here 0, and next same in the similar way D1, and here 0, so here D1, so the D1 bit is nothing but the 1, and now and the finally D0, so here D0, here 1, here Q, and here 0, so here also D0, and the D0 bit is 0. In this way the input will be taken. Now after, if load becomes 1 means the load will be disabled and the shift operation will be start. Now bit by bit will become at the output. At a time a single bit only appear at the output because it is a serial output. Okay. Now what will happen? If shift is equal to 1, here it will be 0 because the signal is 0 and the signal is 1, right? Now what will happen? Here 1 will be there. Now here Q will be there, and here 0 will be there. Q plus 0, here Q will become, that means this 1 will be shifted to here 1. In the similar way it will be shifted to 0, and it will be shifted to 1, and this 0 will become at the output. Now how the output will become? First 0 will become, and for next 1, and next 0, and the next 1, in the reverse manner. We are giving the input as a 1 0 1 0, and it will become as a reverse manner 0 1 0 1. In this way the load and the shift operations will be performed in the parallel in serial out shift register. We can see these output waveforms. Okay. Now I want to give like 1 0 1 0, right? 1 0 1 0. So D3 will be 1, as we discussed in the previous, D3, D2, D1 and the D0. So D2 is 0, D1 is again 1 until the next positive clock cycle, and D0 is 0. Okay. Now in the before that there is a, it will be continued to 0. Now the D3 will be, no, first D0 will become, and next clock cycle D1 will become, and next d2 will become, and next d3 will be come to the final, until and unless it will continue like this only. So in this way, in a single clock cycle, the inputs are taken, and after 4 clock cycles, the output is appeared 0 1 0 1. So in this way, parallel in serial out shift register will be work. Now we will see how to make the Verilog code for this parallel in serial out shift register. Okay guys, now we will start making the Verilog code for the PISO. PISO. So I am giving the name as PISO. Here I will taking the input. We are designing the 4-bit shift register, right? So I am taking input 3 is to 0 PI. PI is nothing but the parallel input. PI 0, PI 1, PI 2, PI 3. In this way, 4 locations will be allocated for the PI. And what are the other inputs? Input clock, and I will take the load, and now I will taking the output register S0 will act like as a serial output. Okay, so these are the inputs and the outputs required for our module. Now I take some temporary register to manage the internal operations. Register 3 is to 0 temp. Now I am using the always at the rate posage clock, that means only posage clock response for the positive edge clock pulse begin. Now if what we will write, is not if load is not equal to 1, then what operation we have to do? Begin. This temp will be taken the input, parallel input. Okay, I'm ending this now. Else begin. Now if load is equal to 1, the shifting operation will be done and the output will be come out. So S0 will be equal to temp 0 bit. Okay, because uh, we are designing like D3, D2, D1, D0, right? So the first D0 output will be come out, then D1, then D2, then D3. In this way, the circuit will perform the operation. Okay. Now the temp will shift one, right shift once. Now I'm ending this module. So this is the design code for our parallel and serial output shift register. Now we will write the test bench module DB. What are the inputs registered? 3 is to 0 parallel input and register clock, and other is load. Okay, now what is the output by S0? Now I will extract the inputs and outputs from the design code. What are the inputs? Clock, PI, load, and finally S0. Okay, now I will give the first clock signal. Initial begin, clock is equal to 1. Now I will write the dump file command so that we can see those output waveforms. File.vcd. Next dump vers 1. Okay. Now I will use the forever command. Forever $5 for every 5 seconds clock will be changed its state. That means it will go to the complement state, and I will end this. Now I will give the main test bench initial begin. Now first I am considering load is equal to 1, so that load equal to 0, sorry. So the load operation will be done. I will give the input like 1010. So the output will be appear like as 0101. I will give some time delay called 10 seconds. Now I will make the load is equal to 1. Okay. For how many seconds? For 10 seconds. We require a 4 clock cycles, right? So I will make like 10 and 4 clock cycles will be required. Now I will give some other sequence, and load is equal to 0 and pi equal to, pi is nothing but the parallel input. I will write 1101. Now it will become like as a 1011. Some time delay. 10. Now again, same like as above, you can write like this, or you can simply write load equal to 1 for how many seconds? For 40 seconds. For 40 milliseconds. Okay. Now I am ending this dollar finish. You can put semicolons if you want, or you can simply write the dollar finish comment. I am closing this. I am ending this and module. So this is the test bench required for our module. Now I am saving this file. Before that, I am selecting the tools and the simulators. Open EPView. I am saving this file. The name called PISO. I mean parallel input, serial output, shift register. Okay, PISO. Now I am saving this file. Now I am running this file once. Yeah, your output is came. Here you can observe that here 1 0 1 0 the sequence is given. Now in the reverse band it will come 0 1 0 1, and another sequence is given is 1 1 0 1, right? So 1 0 1 1. So in this way the parallel in serial or shift register will be work. You can get this code via GitHub. The link will be provided in the description. Thank you for watching this video. Stay tuned for the next one.